Hello friends, my name is Jennifer Sampson. In this particular video, I'm going to be explaining to you about adding a sequence of decimal numbers. So for this particular example, you will see that this is the particular code available over here, and the set of inputs are available at the location 80001, 8002, 8003, 8004. The total number of inputs minus 1 is available over here. I will not specify the total number of inputs. I will specify the total number of inputs minus 1 over here. And this is my particular value of 8000. So this total number of inputs, I will be moving it to a C register over here so that I can count. So that I'll be decrementing the count over here, and I'll be verifying when the count is equal to 0, I will be coming out of this program and terminating it. But until my particular C value is 0 when I'm decrementing, I need to do the addition again and again. And that is what the sequence is about over here. So please remember this number 3 over here is specifying the number of times I need to do this particular operation. So if I have totally 4 inputs, 4 minus 1, 3 is specified over here. If I have 10 inputs, 10 minus 1, 9 is specified over here. So this is what I'm going to be specifying over here. Another thing that you need to know is DAA. What is DAA? It is decimal accumulator adjust. What is going to happen over here is it is going to convert the hexadecimal number into a decimal number. How is it going to do that? It is going to add number 6 to my particular hexadecimal number, and from that I'll be getting my equivalent decimal number. So I need a number 10. Hexadecimal number for 10 is equal to 0A. So how do I get 10 from 0A? I just add 6. If I add 6 to 0A, which is the hexadecimal number, I will be getting 10. And that 10 is nothing but my decimal number 10 now. So please remember 10 is entirely different, 10 is entirely different. If I want 0A to be converted to 10, I add 6 to 0A, which becomes 10, and that 10 is now equivalent to 10. So this is what I'm going to be doing using my DA operation. Why am I using this XCHE? XCHE, please remember it is going to exchange the values of DE and HL register pair values. Okay, so when I'm going to be doing this loop operation, I will be using this XCHE. When we look into this particular program, you'll understand why do we use this XCHE. I've been using this in two places over here. And when it comes over here in DAA, you should notice that when my value is greater than 9, I will be adding 6. For example, 0A or 0B, when it is greater than 9, I will be adding 06 to that number. Another case is that when my auxiliary carry flag is also equal to 1, I will be adding 06. That is the case of DAA operator in 8085. When you look into the definition of DAA operator, please remember you'll have two definitions. When my value is greater than 9, it will add 06, and if the auxiliary carry flag is also set, it will be you will have to add 06 to that. So this normal operation will not be helpful over here. You will understand that when you go through the video again later. So for that, what I will be doing is I will be adding another extra instruction SBI 06 over here. Why am I going to subtract the 06 again? We'll be looking into that when we execute this particular program. So now I'll be executing this particular program line by line over here. I hope I've given you a brief introduction. Now we'll look into the explanation of that. Okay, so what are my inputs over here? 5 plus 5, 10. 10 plus 15 is equal to 25. 25 plus 12 is equal to 37. So I should be getting 37 in my particular location 8050 over here at my output. This is what I'm going to be expecting. So first I'm going to load the particular total number of input value minus 1. Where am I going to load it? I'm going to load it from my 8000 location, and this is now available in the M register. So what am I going to do next? This particular value of 03 is going to be moved where MOV C, M. It is going to be moved to C register. So if you see over here B register, C register. C register now will be updated with the value 3. So it is now going to be updated with the value 3 over here. What am I going to do next? I'm going to be getting my first input. So what am I going to do? I'm going to increment my HL register pair, which is having 008000. You can see that over here. HL is equal to 8000. When I increment that, what will happen? It will become 8001. So it is going to become 8001. What is available in my 8001? My first input. So where do I move my first input? To the accumulator. So move A, M. So M is moved to A register. What is M? It has 05. So 05 is moved to the accumulator. So 00 is now updated with 05. Now what am I going to do? INXH. This loop is not of interest now because it will come here only. So now you consider the INXH only. What is the INXH for? Getting my second operand. What is my second operand? 5. So where is my 5 available? In the M register. So what am I going to do? When I give the increment H register, what is going to happen? 8001 is going to become 8002. So it is becoming 8002. And what is in my M register? The second input of 5 over here. So that 5 is available. Now when I give add M, what is going to happen? Adding my previous A value of 5 with the M value of 5 over here. So 5 plus 5, I will be getting that particular value in hexadecimal 0A. So please remember, I will be getting the value 0A. Now this 0A is in hexadecimal. What do I require? I need to convert it into hexadecimal. So as I told you, if I add 6 to 0A, I will be getting 10. So what am I going to do? DAA, it will add 6 to that particular number. So what is going to happen in my DAA? 0A is now going to be converted into 10, 10. So it is 10 over here. Now I will be exchanging the values of 8002 with D. So what am I going to do is 8002 I'll be putting it into this particular register over here D, and 0000 will be coming over here. So DEHL, both of these are interchanged. Now this is for my output. Where am I storing my output? In 8050. So 8050 is this particular location. So I'm loading that particular value LXI H, 8050 in this particular HL register pair. Why do I need to load this HL register pair value over here is because then only I can move my particular value to M register, which will move that particular value into the particular memory location. So if I need to move a particular value from M to another memory location, I need the HL register pair. So please remember that my HL register pair is the only contact to the outside world. So I will have to move it to M, which requires H. So 8050 has to be uploaded over here. So LXI H, 8050. Now what am I going to do? What is my value? Output 10. So that 10 is moved to which location? 8050. So you look into this 8050 here. Now it will be getting the updated value of 10. So this is my 8050 getting the updated value of 10. Is there any carry generated? I don't think there is any carry generated over here with 5 plus 5 10. So no carry generated means jump not carry. It will go to the location done. So no carry is generated. I'm going to go to the location done over here. So when I come into done, as I told you, you see that auxiliary carry flag is being generated due to this DAA operation. Okay, so auxiliary carry flag is being generated over here. So if auxiliary carry flag is generated, what will happen? If I don't give this particular line, I do the addition again. With this auxiliary flag being generated over here, though my number is less than 9, what will happen? It will add 6 over here when DAA is taking place. Please understand again. If I do not give this S by 06 over here, what will happen by default? Auxiliary carry flag, as I have given it as it is 1 over here, it will change, it will add 06 to the particular next number, and I will be getting a wrong output. This is a drawback. In 8085, the auxiliary carry flag is the only flag that cannot be programmed by a particular programmer. He cannot control it. So in order to avoid that, what I have done is, in addition, in a precaution to that, I have subtracted 06 earlier. So now if I add any number to that, later on in DAA when it is given, as auxiliary carry flag is selected over here, it is going to add that 06 and I'll be getting the correct answer. You will understand that when I add 5 plus 5 10, which is 10 over here, 10 plus 5 15, I will be getting 25. You will understand that when I'm getting that. So now you see that 10 minus 06 will be available SBI, subtract immediate 06. Subtract immediate 06 from where? My accumulator. So 10 is now going to become, sorry, it is 10 going to become 0A because 10 minus 6 is A. So now my accumulator value is A over here. Next, what am I going to do? I'm going to decrement my C. C register is 03. I'm going to decrement that. Now when I decrement that, it is checking where it later I have to check whether it is 02. Before that, what am I going to do? My next input is available where? In 8003. So what should happen? When I give this INXH over here, please remember, when I come back into this loop, when I give INXH, this 8050 will be updated. It will not be 8002 which will be updated to get the next input. 8050 will be updated over here. So in order to avoid that, what I'm doing is I'm giving this to XCHE over here. I hope you now understand why did I give these two XCHEs over here. Now when I give this XCHG, what will happen? 8002 will come into HL, 8050 will go into DE. So this is what is going to happen over here. So now you will see that both of these values are exchanged. So 8002, 8050, exchange the values. Now when I decremented C, was a zero generated over here? No, zero flag was not generated over here. So if zero is not generated, what am I going to do? I'm going to go back into the loop over here. So this is what is going to happen in my next step. So now what am I going to do? 8002 is over, 5 plus 5, 10. Now this 10 plus 15 has to take place. So where is it available? 8003. So increment H. So 8003. Now what am I going to do? Add 15 with this particular 0A. So please remember auxiliary carry flag was generated over here. Though there is a value greater than 9 or not, what is going to happen? It is going to add 6. So whatever I done in advance over here, I have subtracted 6 over here. So please remember now 0A plus my new value 15. This is what is going to happen over here, 1F. Now I should be getting 25. You may remember 10 plus 15 is 25. How will I get the 25? DAA will now add 6. How will it add 6? Auxiliary flag is already enabled over here. It is going to add the 6 and I've now got the 25. So 5 plus 5 10, 10 plus 15 is 25. So I've got the 25 in this particular input over here. Now I hope you understand why did I give this SBA06 over here. Auxiliary carry flag cannot be programmed by the 8085 programmer. So please remember that. Okay. So next one is again I have to exchange the values. So what am I going to do? 8003 back to DE, DE value back to over here. So what is going to happen? It is now exchanged. Now what am I going to do? Load immediate 8050. So this value is being loaded into HL register pair. Anyway, same thing is going to happen. Now what am I going to do? 25 is moved to where my 8050. So now this 10 is going to be replaced by my particular new value, which is 25. Now, any carry generated, no carry generated, carry flag is 0. So, no carry generated, come to done over here, 15th line. So, it is going to come to done over here. Now, 25 minus 6. As I told you, auxiliary carry flag is set over here. So, I subtracted 0, 6 over here. So, 25 minus 6, what is going to happen? It is going to become 1F. Now, I'm going to decrement my C value. 0, 2 is going to be decremented to 1 over here. So, it is decremented to 1. Now, I'm going to exchange the values of 8003 and 8050. So, I'm going to exchange that over here. And is my zero flag generated? No, it is not generated. So I have to go back to the loop over here. So I'll be going back to this location. Where is my next input available? 8004. And what is my value? 12. So now what is going to happen? I'm going to increment this H value by 1. So it is going to become 8004. So 8004, what is my value? 12. 12 with my new 1F value. If I add that, I will be getting 31. But what is my actual value? 5 plus 5, 10. 10 plus 15, 25. 25 plus 12 is 37. So how will I get that? Auxiliary flag generated. It is already enabled over here. Now when I convert it, what is going to happen? I'll be getting 37. So if I had not given this SPA06, it would not have given me the correct answer. It would have given me plus 6. 37 plus 6 would have been the answer. You can try it. Okay. Try removing this SPA06 from your program and bring this DCRC to the previous line over here. Try executing it. You will be getting your answer plus 6, as you will be getting plus 6 always in your answer. If you had expected, for example, 5, you will be always getting 0B. You will be getting plus 6 in that particular answer. So now what am I going to do? Again, exchange this particular value over here. When I exchange this particular value, 8004 is gone back over there. HL is coming over here. Now I'm going to load that particular value. What is my output? 37. 37 is moved to where? My particular output location 8050. And that is my 37 over here. No carry generated. You see that no carry is generated over here. Now it is going to come to done. Now I'm going to subtract this A value. I don't care if I'm subtracting this now, because what is going to happen next? I'm going to decrement my C register. When I decrement my C register, you see that my zero flag is enabled over here, because now that value is 0. After I decremented, the register became 0. So 0 means my zero flag is now enabled over here. Now for formality, I'm going to exchange these particular values over here. Jump not 0, go to loop. Now if it is jump 0, go to this particular location, halt. So please remember, now it is 0. So what will happen? It will not go to loop. It will come out of this particular location, halt. And this is where my program stops. So please remember, this is a requirement of adding a sequence of decimal numbers. Exchange XCHG, XCHG in two locations. Try removing them. You will understand the purpose of these two XCHGs over here. Try removing the value of SBA06 over here. You will understand the value of you will understand the reason why you added this SBA06, because the output that you're getting will always be a plus 6 number greater than the output expected. So try doing this. I hope you'll be getting clarity on that. Thank you so much.